Good morning, students. Let's start with a new topic. There are few small topics that I have left in the class. So I want to recap with that topic. The first topic is memory interleaving. In the last lecture, I have upload a question on hit ratio, and I have also discussed about how to solve that particular numerical on hit ratio, number of miss, access frequency. So please go through that uh, because that is important numerical. And apart from that, please practice the page replacement algorithm. These are the few numerical that was asked in the semester exam. So please go through that. So let's start with the first topic. These are the small two topics I will discuss in this video. So please go through this. The first one, memory interleaving. That means memory interleaving means we divided the memory into number of modules. We divide the complete memory module into number of modules. Why? There is a certain task for that or certain use for that. So it is a technique to increase the throughput. Why we are doing this? To increase the performance. How? To increase the throughput. We reduce the access time. If if some instruction take let's say 1 unit time to access a particular data, apart rather than taking or giving 1 minute, if it take 30 seconds only, so the performance will increase. So this time is generally known as the throughput. We have discussed in the performance parameter also. So it is the technique to increase the performance. To be more specific, increase the throughput, where the memory system is divided into independent banks. So generally a complete memory is divided into number of memories. So let's take a simple example. Let's say all the odd number and even number are stored in a single memory. If I want to access an odd number, I have to access the same memory. If I want to access an even number, I have to access the same memory. So there is a chance it will take more time to access the even number, because I have to pass through all the numbers to get that particular even number. And when we are passing through the memory address to get that particular even number, there is a probability we will came across a odd number also. So if we divide the complete memory into two parts, one memory module is responsible for the odd number, storing the odd number, and the other memory module is responsible for storing the even number. So now my uh, task is more easy. If I want to access even number, so I will access the module 2 directly. I can access the module 2 because I already know this module contains the even number. And the vice versa, if I want to access the odd number, I directly access the module 1. So this increase the throughput and hence increase my performance. So this is a simple example of odd and even. So same I have written. See, so it is a technique to increase the throughput. How? The memory system is divided into independent bank. Again, independent. There is no dependency over the different modules. So this is done by, see, this is done by interleaving the address space. Consecutive cells in the address space are assigned to different memory banks. That means consecutive. It is a contiguous manner. Contiguous. Let's say the memory space is, let's say the capacity of the memory space is 40. So I will divide 1 to 20 in one slot and 21 to 40 in one slot. This 1 to 20 must be contiguous. That means consecutive memory address. So for example, I have written, let's say in a two module memory system, there is a two module. Let's say there are two module is only there. So even addresses may be accessed using one module and the odd addresses in the other module. Different example. Let's say this for read and write operation. So let's say few data are available for the reading operation and few data are available for the write operation. So I can divide this two module into two module. one module contain the data that is responsible for reading purpose, and one module contain the data that is responsible for writing purpose, to increase the throughput. Simple. So generally memory interleaving is what we are dividing the complete memory into number of small modules. There's, and there should not be any dependency. What is the use? To increase the performance, to be more specific, to increase the throughput. Example is what? Odd number and even numbers, you can do that. So there are types of interleaving. This is generally the types of interleaving depends on the address format. And so what I have written, low order interleaving and high order interleaving. So you don't have to worry about this. Just with this name, I will go to the definition later on. With this name, I want to just make it clear. This is the two address format that is responsible for memory interleaving. That means I have to divide what I have told. If there are 40 number of addresses, so 1 to 20 in module 1, 21 to 40 in module 2. So low order interleaving means I am creating a address format. So there must be some lower order bits and higher order bits. We have this, you already know, the MSP, most significant bit, and the LSP, least significant bit. Similarly here, low order bits and high order bits. So similarly, this low order, high order, see, I have written the low order bits are used for memory address, that is memory module, and the higher are used for the word in that particular module. That means, let's say the complete memory is divided into two modules. So in the case of low order, in the case of lower order, so lower bits are used to define the memory module. That means which memory module out of there, if there are two modules, which memory module first you have to access. If I got that, then out of that particular module, which word I want to access. That means first I have to select which module, and then I have to select which word. So in the case of low order, the lower bits are used to define the first the module, and the higher bits are defined, higher we are used to define the word. And it is the just the reverse of low order is high order. Same here, in the case of low order, lower order bits are used to define the memory module. So in the case of high order bits are used to define the word. So it is the just the reverse of that. So there are two address format of the memory leaving, low order and high order. So if the memory is divided into two modules, let's say module 1 and module 2, the first address, the address should be defined in such a way that first it will select the module, and then out of that module it will select the desired word. So in the case of low order, the first low order bits define the which module, and the high order bits define which word of that particular module. And the high order is the reverse of the low order. So this is all about the interleaving part. And there is one more topic, that is memory management unit. So by the name, memory management unit, that means there is some hardware is there that is managing all this memory. So what I have written, it is a computer hardware component. It handles all the memory and caching operation associated with the processor. That means all the memory linked with the processor for doing the operation. So it contains two parts. First, it contains a table for translation, and it contains a buffer for translation. So I have written the first the table walk unit, and the second one is TLB, translation look aside buffer. This one is more important. Please note. TLB, translation look aside buffer. We have already discussed in the earlier class also, that means whenever a CPU generates an address, it is either a virtual address or logical address. But the data stored in the main memory has physical address. That means this logical or virtual address must be converted to physical address, and then using that physical address, particular data can be accessed. because all the data is stored in the main memory having physical address. So all this translation of the virtual or logical address into physical address is done by the memory management unit with the help of table walk unit and TLB unit. So I have written all this memory address issued by the software, let's say software are virtual or logical. So translation of this address to physical is done by MMU using TLB and table walk unit. So this is a simple about MMU. We have already discussed indirectly, but I am making this video to make aware about this terminology of this terminology like MMU, interleaving, and again the instruction format. We have already discussed in the addressing mode. But just I want to familiar with this word. So again, the last topic for this video is instruction format. We have already discussed about this in the addressing mode also. But my concern of making this video is to make you aware about this technical words like instruction format. So there are generally instruction format means what is the format of the particular instruction. That is nothing but the addressing mode. So there are 0 address format, 1 address format, and 2 address format. What are they? With the example, you can all say this is self-explanatory. 0 generally we have discussed 1 address and 2 address. So 0 address means there is only opcode. There is no concept of operand. Opcode, either let's say ADD, add, MOV, move, STR, store. So there is only opcode that is stored in the memory. That is known as 0 address format. 1 address, that is opcode and operand, what we have discussed in the addressing mode. So there is a opcode and there is a operand on which this opcode will work. 2 address, again we have discussed this in the addressing mode, where there is a base address and there is a some address of the register. Both are added and that will lead to the address where my data is stored. So opcode address 1 and address 2 both are added to get the final address where my data is there, operand is there. So these are the instruction formatted. That is 0 address, 1 address, and 2 address. So that's all for this video. Hope this will make you aware about these technical words. If you have any doubt, you can contact me. So that's it for this. Or I will upload more topics with new video. Thank you.